Welcome to the Explainer. Grab your UV lights, get your forensic kit ready, because today we are walking straight into a mathematical crime scene. We are officially opening case file the failing high tariff question. Our mission today is investigating exactly how Cambridge Mathematics 9709 students are getting absolutely robbed of easy marks on section 2.4. That's parametric and implicit differentiation. You know the exact scenario I'm talking about. You walk out of the exam room feeling great, confident, maybe even a little cocky. But then results day rolls around and those marks, they've mysteriously vanished without a trace. Well, today I am your lead detective, and I've actually brought in my two rookie forensic agents to help frame this up. We've got Agent Alex, who is completely obsessed with the hard facts and loose footprints, and Agent Sam, who tends to get lost in vague theories. Together, we're going to string up the yellow tape, break down the examiner reports, and figure out exactly where your missing marks are going. By the end of this investigation, you won't just be solving equations. You will be completely bulletproofing your exam papers against the most common fatal structural drops. So let's start with the central mystery of our case. Where do the marks actually go? Why is it that students who have spent literally hundreds of hours memorizing the chain rule, the product rule, the quotient rule, why do they suddenly freeze up? Why do they find applying these theoretical concepts to unfamiliar contexts so incredibly difficult? My rookie agent Sam always says, it's because the vibes are off in the exam room. But no, Sam, it's not the vibes. It's not because you don't know the math. It's because you don't know how to document your investigation. In parametric and implicit differentiation, you are often dealing with complex curves that aren't those nice, simple y equals f of x functions. You're dealing with a third variable, a parameter like t, or an equation where x and y are just tangled up together. And when candidates face these unfamiliar scenarios, panic sets in. Agent Alex always points out that students just jump straight to the final answer in their heads. They completely forget to lay out the evidence. And in the Cambridge exam room, listen to me carefully, if there is no evidence, there are absolutely no marks. Okay, let's dive into this. Section 1, the incident report. Before we can catch the culprits stealing your marks, we really need to understand the laws of the land. We're talking about the core academic benchmarks required for Cambridge Mathematics 9709. The syllabus strictly, and I mean strictly, prioritizes logical, structured reasoning. Top-performing students don't just calculate things. They exhibit a connected conceptual understanding that is completely transferable to any unfamiliar context. The exam board isn't testing whether you can regurgitate a formula you crammed the night before. They're testing whether your systematic analysis is actually sound. So, our primary forensic tool here is the method mark strategy. This is the absolute golden rule of Cambridge Mathematics. Earning marks is entirely about leaving a clear, logical evidence trail of your mathematical process, rather than just relying on a correct final answer. Think of the examiner as a judge. You can't just run into the courtroom and yell out who committed the crime. You have to prove it step by step. Let me give you an example. In implicit differentiation, if you differentiate y squared to 2y but you fail to explicitly write down dy dx right next to it, the chain of custody is completely broken. The method mark is lost, just like that. Examiners are actively looking for systematic analysis and evidence-based reasoning. Your working out isn't just scratch-pad scribbling. It is the literal, physical evidence trail left behind for the examiner to award you points, even if your final arithmetic goes slightly wrong at the very end. To really get inside the examiner's mindset, we have to look at their target domains. The assessment objectives for 2.4 differentiation target three distinct cognitive domains: knowledge, application, and analysis. Knowledge is your basic toolkit, right? It's knowing how to differentiate a parametric equation involving sine and cosine. Application is taking that toolkit and actually using it on the specific curve provided in the exam paper. But analysis? Oh, analysis is where the heavy lifting happens. The framework strictly prioritizes analytical depths over superficial breadth. Honestly, they don't care if you vaguely know 10 different mathematical rules. What they care about is if you can deeply, analytically apply the one correct rule to find the exact gradient of a tangent at a specific point on an implicit curve. That depth, that analytical rigor, is what actually secures those high tariff points. All right, let's keep moving. Section 2, analyzing the evidence trail. We're transitioning now from the theoretical rules to the actual procedural framework. From this moment on, I want you to treat your exam paper strictly as a physical evidence trail. Every single line of algebra, every substitution, every derivative you write down, that is a footprint you are leaving for the examiner to follow. If you skip steps, you are essentially wiping away your own footprints. You're making it impossible for the examiner to follow your logic. Agent Alex and Agent Sam were just cross-examining a student's text line by line under a UV highlighter graphic in the lab, and they found the exact point where a student misread the command word. It caused a fatal structural drop.
To ensure your footprints are perfectly preserved and you avoid that drop, Cambridge requires a standardized sequence. Here's the exact forensic methodology for solving these complex parametric and implicit problems. Step 1. Identify key elements. Deconstruct the given information first. Are you looking at a parameter t? Step 2. Apply relevant principles. Select your analytical framework. Do you need to find dx dt and dy dt to eventually get dy dx? Step 3. Execute the analysis with clear working. This is where you write down the algebraic manipulation without skipping a single beat. Step 4. Verify your results. Stop and check for reasonability. Step 5. Present in an appropriate format. Are your final coordinates clearly stated? Is your final equation of the normal in the exact form requested by the question? Because let me tell you, if you miss that final presentation step, you drop the final mark right at the finish line. It's heartbreaking. And this brilliantly illustrates the data interpretation skills demanded by the syllabus. The mandate is to, quote, extract from texts and tables, interpret relationships, and draw evidence-based conclusions. Now, in the context of pure mathematics, extracting from text means reading the question incredibly carefully to spot constraints. For example, is there a domain restricting the parameter t to strictly positive values? Interpreting relationships means understanding exactly how x and y behave together on an implicit curve. So think of this as our first live viewer challenge. Imagine a 60-second visual timer right now on an authentic exam question. Could you locate the critical trend variable in that time? Because if you don't extract the correct parameters right at the start, your entire investigation is headed in the wrong direction before you even pick up your calculator. Which brings us to Section 3, the lineup of suspects. But hey, detective, let's pause the case file for just a second. To ensure you never miss our weekly forensic investigation breakthroughs, and to guarantee you always outsmart the examiners, you need to subscribe to Ace the Exams at the handle @AceTheExams right now, and make sure you turn on all notifications. Okay, back to the case.
So we've pulled the principal examiner reports. These are basically the historical crime logs from Cambridge. These reports document exactly where thousands of students went wrong globally. Let's see who is in the lineup today, shall we? We are going to treat these frequent exam mistakes as the actual culprits stealing marks from your paper. Here are the top 3 examiner warnings, straight from the forensic lab. Suspect number 1, confusing cause and effect. In parametric equations, students constantly invert the chain rule. They calculate dx over dt over dy over dt instead of the other way around, fundamentally confusing the relationship between the variables. It's a disaster. Suspect number 2, forgetting to check format and presentation. You do all the brilliant calculus, you really do, but then you leave your final answer as a complex, unsimplified fraction when the question explicitly asked for the form ax plus by plus c equals 0. That is a fatal error. Suspect number 3, providing generic answers without context. The examiner asks about the gradient at a specific point, and you provide a general derivative without actually substituting the coordinates back into the context of the curve. You've got to use a solid structural template here, something like the Peel template, point, evidence, explanation, link, to ensure your mathematical argument actually links back to the scenario. These 3 culprits are absolutely lethal to a top grade. Let's do a live forensic workshop right now for our second challenge. The crucial point is understanding the difference between a weak response and a bulletproof one. I'm looking at a flawed student snippet. A generic answer is incredibly superficial. A student might write down the implicit derivative beautifully, sure, but then they completely fail to apply it to the specific coordinate given in the scenario. It completely lacks the scenario link. Contrast that with the evidence-based contextual answer. In this newly engineered version, every single point is linked directly to the given context. The student explicitly substitutes x equals 2 and y equals 3 into their derived dy dx formula. They clearly state the gradient value for that exact point. The principal examiner's ultimate alert is this: the classic mistake is providing generic answers. Always link every point to the given scenario. If you don't, you are solving a hypothetical crime, not the one that's actually sitting on the desk in front of you. Now, we know exam environments are high stress. Your adrenaline is pumping, the clock is ticking down, and it is so easy to just drop your forensic protocol. So we've engineered a memory hack to help you lock down the framework under severe exam pressure. Remember the acronym IAEVP. Identify, apply, execute, verify, present. I want you to burn this into your mind. When you open a high-tariff parametric differentiation question, do not just start writing blindly. Stop. Take a breath, think. IAEVP. Identify the variables, apply the chain rule, execute the algebra, verify the logic, present the final format. If you use this hack, you are guaranteeing that your evidence trail is completely unbroken from start to finish. All right, we are nearing the end of our investigation. Section 4, the final autopsy. This is where we reconstruct exactly how elite candidates secure maximum points. We've seen how marks die, now we need to see exactly how marks survive. How do the top 1% of Cambridge candidates think when they are faced with an unfamiliar implicit function? Well, they rely on higher-order problem-solving techniques. Step 1. They deconstruct. They pull apart the text, isolating the implicit equation from the boundary conditions. Step 2. They solve systematically, in logical steps. They don't jump ahead. They write down the derivative of every single term clearly, respecting the product rule when x and y are multiplied together. Step 3. They evaluate and check for reasonableness. They actively question their own assumptions. If they get a gradient of 0, they stop and ask themselves, does the curve actually have a horizontal tangent here? They evaluate alternative interpretations, and they justify their decisions with solid algebraic evidence. This descriptive, analytical, and evaluative layering is exactly what Cambridge demands for the highest tier of marks. To wrap up our findings today, I am officially issuing you all the Forensic Exam Protection Checklist. As you practice your past papers, you absolutely must enforce these rules. First, apply correct formats. Always double-check the final form requested by the examiner. Second, use appropriate terminology. Write dy by dx, write dx by dt. Use the proper mathematical vocabulary to signpost your working out. Third, make justified recommendations, which in pure math means proving your final result based on the explicit algebraic steps you've shown. Like my agents Alex and Sam read out from that full mark paragraph earlier, if you show the substitution, state the gradient, and format it perfectly, they can't take the marks away. If you practice past papers using this exact analytical framework, your marks will be completely protected. Which brings us to the ultimate question for you to answer today. Are you leaving a bulletproof evidence trail for the examiner, or are your marks getting lost at the scene of the crime? The next time you sit down with a 9709 past paper, I want you to think exactly like a lead detective. Protect your marks, document your evidence, and leave absolutely nothing to chance. Now, to make sure your exam strategy is fully locked in and ready for the real thing, I need you to command that subscribe button for Ace the Exams at the handle @AceTheExams. Enable your notifications so you never miss a case file, and drop a comment below right now telling us your current level and your target grade. Class dismissed, detectives. I'll see you in the next explainer.